Okay, so product and quotients of functions. So what we're looking at the start here is even and odd functions. Now an even function is symmetrical about the y-axis. What that really means is that f at x is equal to f at negative x. So if we're looking at very common ones, we're looking at things like a quadratic. If I look at the negative value and the positive value of x, they're the same thing. We're going to get the same y value. It doesn't always, if I move this graph, it's no longer symmetrical but the y-axis. But as long as it's on that axis, as long as I don't have a horizontal move, this is going to be true. Another common function is like a cos graph. It's not thought of as much as like a quadratic or a quartic, but you can clearly see that it's symmetrical about the y-axis. Odd functions are rotationally symmetrical. It's almost like a point of inflection. So with that being said, like a cubic is a very common one. Even like y equals x is a very common graph. One that's not thought of would be like the sine graph. The sine graph you can clearly see is symmetrical about, or rotationally symmetrical about the origin. Okay, it flips at the origin. It's like a point of inflection. Okay, where we've got -1 here and +1 here. If we were to put those values in, we'd get the same thing. All right. Considering functions, what we're doing here is we're just looking at whether they're odd or even in the degree. This is rotationally symmetrical for the odd ones, excuse me, and the even ones are symmetrical about the y-axis. So if I'm looking at multiplying functions, I literally just multiply them together. Okay, this one, what's going to happen? We're going to have an odd and an even, which will become odd. Okay, here we've got an odd and an odd, which becomes even. Here we've got, again, an odd and an odd, which is even. And here we have two evens, which stay even. This one, you're just kind of doing it in order. Odd and even becomes odd, and then two odds would become even. All right, there's a little mistake on this next one, but when multiplying two functions, or two even functions, you get an even. Two odd functions, you also get an even, not an add or an odd. Think of like x cubed times x cubed, you're going to get x to the 6. Okay, that's an easy way of thinking of it. When multiplying an even and an odd, you get an odd. So if I were to look at this function, I've actually multiplied it together, but what I did first was I factored this. Okay, now I've left the graph at the bottom blank. I want you guys to try it. I'm going to go through all the parts. I want you to remember back to when we were graphing. But here, this allows me to see the zeros. I can see there's a double root at x minus 3. I've got x minus 5. It's an odd degree, so that tells me my end patterns of my line. Our leading coefficient's positive. Our y-intercept is 45. I can tell you the domain and range are all real numbers. Give a shot. Remember, that's a double root. All right, looking at this one, we're dividing here. It's a little bit harder, obviously, but if you remember back and you factor that, you can cancel out these x plus 3's. That makes a point of discontinuity at x equals -3 and y equals 0.5. Okay, if I sub in x equals -3 here, we're going to get 1 over 2, which is 0.5. Our vertical asymptote is at x equals -5. Our horizontal asymptote would be at y equals 0 because we haven't moved up or down. There's zeros, there's no x-intercepts, and our y-intercept is at 0.2 or 1 over 5. If we graph this, it's going to look something like that, where we've got our discontinuity, we've got our two lines, domain and range are a little bit longer. I wrote them like this. I didn't have the infinity symbol, so I didn't write it in. I just wrote the word infinity. But we're going from -infinity up until -5, from -5 to -3, and then -3 to positive infinity for my domain. And the same thing is happening here with my range, but we found out that was 0.5 by subbing in -3 to our discontinuity. Okay, and then a few key points here. We're representing the product of two functions. We've got our discontinuity, and the domain and range are constant.